Hey guys, we're going to talk about a couple things that you might see in a table that have a possibility of tripping you up. And we're going to take a nice look at those so we can see what's going on. So here, nice and easy, 1, 2, 3, 4, one step at a time. That's what you were seeing in the last one, 1, 1, 1, 1. It gets repetitive and boring, and I've got a jump of 1 here. So I figure my slope then is just 1/1, and it's 1, right? The problem is you've got to check to make sure that it's linear because we've got a situation here where there's not a constant rate of change. And that means that this table is not linear. So we're not going to write a linear equation for that. In fact, that equation would be y equals x squared. As you can see, 1 squared, 2 squared, 3 squared, 4 squared. We'll get to those later. But this is not linear, so we can't write a linear equation for this. That's something that you have to watch out for. Another thing that you have to watch out for is the jumps on your x's. So from -1 to 2, 0, 1, 2, that's 3 steps, plus 3. From -3 to 3, it's 3 to 0, and then 3 more to 3, that's plus 6. Plus 6. From 2 to 4, that's plus 2. Oh, well, this isn't consistent. Does that mean we're not linear? I don't know. Let's keep checking. From 3 to 7, that's plus 4. From 4 to 8, plus 4. From 7 to 15, that's plus 8. We've got all these numbers here. It's nice and easy to just say that this is not linear, right? How could this be a constant rate of change when I have all these different numbers? Well, let's look. We have our change in y. We know that our slope is change in, the delta is change in y over the change in x. So for the first one, my change in y, 6, over my change in x, 3. Well, what's 6/3? It's just 2, right? So let's try it again with the other one. My change in y, 4, over my change in x, 2. Well, what's 4 over 2? It's just 2. Let's try the next one. Change in y, 8. Change in x, 4. Well, what's 8 over 4? It's just 2. So it's really just constant, right? Because if I take 1 step, I'm jumping 2. So of course, I took 3 steps, so I had to jump 6. I took 2 steps, so I had to jump 4. I took 4 steps, so I had to jump 8. Because for every 1 step, I jump 2. Just because we skipped some numbers in between here does not mean that this is not linear. You just have to check, make sure that you check your change in y over your change in x. That's your slope. How much does my y change for how much my x changes? So be careful of that.